All right, guys, today we're going to multiply matrices. We're going to multiply matrices. Yesterday we added and subtracted them. Today we're going to take it up one level and go to multiply. Real weird rule here, but you got to get this. You're only allowed to multiply matrices if the number of columns in the first one is equal to the number of rows in the second one. Kind of weird to understand, and I'll show you what that means exactly in a second. Also, the answer or the product will always be the number of the rows in the first one, or A, by the columns in the second one. And here's exactly what that means. If you look at these two middle dimensions right here, matrix A and matrix B, also remember that all matrices are named with a capital letter. If you look at the two middle dimensions, they're the same. They have to be the same in order to multiply. If they are not the same, you cannot do the problem. You cannot multiply them. And the answer are the other two dimensions. These two dimensions, the outside dimensions, are what your product will be or what your answer will be. Your answer will be a 2 by 4. So you're allowed to multiply 2 by 3 times a 3 by 4 because the two middle dimensions are the same. Your answer will be the two outside dimensions. Okay, let's look at a couple of examples of this. See if we're allowed to. If you look at this one, matrix A times matrix B, look at this very small right there. Let me see if I make it a little bigger for you. There we go. The two middle dimensions are the same. They're both 3, so that's good. Now you got to tell what kind of product you would get. You would get matrix AB, which would be a 4 by 2, the two outside dimensions. The second one, matrix A times matrix B, because that's a 4 and that's a 3, we're not allowed to multiply those, so that is not possible or is undefined. So not defined. I guess I should have written undefined. Already started. Not defined. Again, the two middle dimensions must be the same, and your answer is going to be the two outside dimensions. I'm going to show you 2 or 3 here, just examples of how I haven't even talked about how you multiply yet, as much as just that when you can and when you can't. And here's the rule for when you can. When you're not allowed to do it, I'm going to read this to you and see if it makes any sense. It says to find the element in the ith row of the jth column of the product of matrix AB, multiply each element in the ith row of A by the corresponding element in the jth row of B, then add the products. Yeah, kind of hard to understand that way, but here's basically what we're going to do. We're going to go, when we're looking for our new metrics, like that's a 2 by 2, got the highlighter on, that's a 2 by 2, that's a 2 by 2, so we're allowed to do it because the twos are the same, and our answer is going to be a 2 by 2. And to get the first number there, I'm going to take the first row in our first matrix, the first row in the first matrix, multiply it by the first column in the second, add those products together and get my first column. When I go to my second row, my second spot, I'm going to still use, because this is in the first row in the second column, I'm going to multiply the first row times the second column and add the two numbers together. When I go to here, that is the second row, first column. I'm going to multiply the second row times the first column. I'll keep going across and down, and add those together. And one more. When I go here to my second row, second column, I'm actually going to multiply the second row times the second column, add the two together. Not as hard as it looks kind of crazy. And if you read the directions, it sounds really crazy, but we got this. So let's try one. First one says multiply if AB is that 2 by 2 and B is that 2 by 2. Now I'm allowed to do it because they're both 2's. My answer, I keep writing in the highlighter. My answer is going to be a 2 by 2 because my outside numbers are 2 and 2. So it may help you at first to draw some blanks in here so you can kind of see what's going on. But what I'm going to do is I'm going to start with this first row and first column right here, the first blank. So I'm going to multiply, sorry, to get that, I'm going to do the first row times the first column, going across and down. 1 times 5 is 5. 4 times 9 is 36. Okay, so that's going to be that's the number that's going to represent the first blank there. In my second blank, now think about what this blank is. This is the first row, but the second column. So I'm going to do the first row. Don't do that. First row times the second column. And if I multiply those, I will get 1 times negative 7 and 4 times 6. I'm going to add those together in just a second. Now I'm going down to second row, first column. Second row, first column, you're going to multiply the second row times the first column. So I'm going to multiply the 3 times the 5 and the negative 2 times the 9. Add those together. And then to get my last row, my last spot here, that's the second row, second column, or last row, last column, I'm going to multiply the second row times the second column. And when I do that, I will get 3 times -7 and -2 times 6. So it'll be -12. So my final answer here, when I multiply those two, is just add the numbers. 5 plus 36, -7 plus 24, 15 and -18, and -21 and -12. So the math part is not that difficult. It's keeping track of where you are in your product and knowing what to add together, what to multiply. Again, the pattern, you go across one row, down a column, across a row, down a column. You just keep going across and down. Look at a couple more here. Okay, using the given matrices, evaluate the expression. What they're asking me to evaluate here is A times B plus C. We're going to use order of operations. So what I'm going to do first is this. I'm going to do the B plus C, which is what we did yesterday. So B plus C, I'm going to add B and C together. That's these two. And they have to have the same dimensions. Remember, addition and subtraction, you have the exact same dimensions. With multiplication, that's not necessarily the case. The two middle ones have to be the same. But in addition and subtraction, they have to be exactly the same. So just add straight across like we did yesterday. That's a 4, that's -2, that's -3. So there's the B plus C. Here's matrix A over here. Matrix A is a 3 by 2. This one, my new one, is a 2 by 2. Because the 2's are the same, I'm good to go. Because my outside numbers are 3 and 2, I'm going to get a 3 by 2. So I'm going to go ahead and draw that down here. A 3 by 2 means 3 rows and 2 columns. So I'm going to go 3 rows, 2 columns, 3 rows. I'm kind of making my blanks a little bit bigger because I think I'm going to have 3 numbers in each one. So here I go. I'm going to go same pattern. Looking first here, my first blank is my first row, first column. So I'm going to take my first row times my first column and just multiply. 4 times -2 is -8. 3 times -2 is -6. Remember, we're going to add those together all the time. We're always adding. Now I'm going to the second one. I'm going to this blank right here. So I'm going to go, still first row, but now second column. So I'm going to first row, second column. Multiply those. 4 times 4 is 16. 3 times -3 is -9. Keep on working. I'm here now. Where is that? That's a second row, first column. So I'm going to go second row, first column. So I'm going to go -1 times -2 is 2. -2 times -2 is 4. Add those. Same process. This one right here now. Second row, second column. So I'm going to go second row, second column, second row, second column. That'd be -1 times 4 and -2 times -3. Now, I'm on my last row finally. So I'm here. That's my third row, first column. So I'm going to go third row, first column. 2 times -2 is -4. 0 times anything is 0, so I'm going to put a 0 there. And finally, I'm at my last spot. I'm at my last blank, which is third row, second column. So one more time, I'm going to go third row, second column, which is going to give me, let's see, 2 times 4 is 8, and then 0 times anything is 0. And to get your final answer here, all I'm going to do is add up all those numbers. So -8 and -6 is -14, 16 and 9, 2 and 4, -4 and 6, -4 and 0, 8 and 0. So that's a doozy, but look what all we did. We actually we had an expression to evaluate. We had to add and then multiply, and we were able to do it. So, you got to just, again, you have to just keep straight where you are. Go across the row, down a column, multiply, add. Mathematically, it's not hard. The work's not hard. You just have to keep up with where you are. That's the main thing. Okay, a couple properties here and we're done. Little k is a scalar, a, b, and c are matrices. Associative property is true for multiplication, like you would think. It doesn't matter how you group them. If you have 3 multiplied, you can group however you want to. Distributive property works both ways. You can put matrix A, work what's in the parentheses first, or you can do matrix A times B and matrix A times C and add them up. I think it's a little quicker actually to do the addition first and then multiply one time, but that's me. But distributive does work either way. Also, if you have a scalar, you can do one of two things. You can do your product first, then take the scalar through. You can take the scalar through one of them and then do your multiplication, and that's the same thing. So 3 options with the scalar. Multiply first, take the scalar through, or take the scalar through one of the matrices and then multiply. So those are the properties that work. Believe me, we'll work quite a few of these until you get the pattern down. Once you get the pattern down, you're going to be good to go. But like I said, because the math isn't that hard. So I'll see you tomorrow. We'll work on it like we always do. See you, bye.